Okay, we're playing now in, this is surveying, of course. We're playing now with level, which is chapter 7 and chapter 8 of your text. So chapter 7 and chapter 8 of your text. So let's see, the titles of those two chapters, if you need them, are chapter 7 is leveling and chapter 8 is lasers. Okay, laser is just a fancy word for a level without a person behind it. Sends out an infrared ray, and that does the sighting for us. So let's go about it. Okay, level. Level has to do with vertical control, elevations. Okay. So when we're dealing with leveling, we've got the level and we've got the laser are our two primary ones out in the field. So we've got a level and a laser. Okay, we'll be playing with both of them. The level takes a tripod, which holds the level. The level sits on the base of the tripod, and the level is basically a magnifying glass on a stick that has a line going through it, and that line allows us to read a number on a level rod. So out here somewhere, we're gonna have someone holding a rod, and this is what that rod looks like. Okay, the rod is a measuring device that is exactly the same as, almost too big for the room, is exactly that same tape measure you used in class. If you lay that tape measure on this stick, all the numbers will match up. It's a little different to read, but they'll all match. Okay, on a level rod, the red numbers are feet. Okay, and you can see that those red numbers emanate off of the top. So if I look at this thing, it looks like this. Okay, each one of these little marks, and there's 3 of them that you'll see. One looks like that, one looks like this, and the other one looks like this. Okay, this is the big red number. Okay, you can see that this is either protruding at the top or the bottom. Okay, reading this isn't too hard, but some people get really confused. So I'm going to write it down, and I'm going to go, actually it's probably easier for me just to show you on the stick. I'm going to show you how you read it. The red number that's 5 foot above the ground. That's 6 foot above the ground. That's 4 foot above the ground. Okay? Each of the black numbers is 1/10 of a foot. The little lines in between represent 1/100th of a foot, or 1/10 of a tenth. So if I was to read this, so watch me, 5.00 feet. The bottom of the line is always an odd number, so that line right there, the bottom is odd, the top is even, every time, okay? So watch me, 5.00, the bottom is 5.01, top is 5.02, bottom 5.03, top 5.04, and then that little line protrudes out is 5.05. 06, 07, 08, 09, and then the top is the 10th, 5.10. Then I go 5.11, 12, 13, 14, 15, 16, 17, 18, 19.20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So when you read this thing, there's going to be a line that you're going to look and see when you look through the level. Wherever that line crosses this level rod, you read the number. So once again, the big red number is feet. The black number is tenths. The lines between the tenths is 100ths. The bottom of the little black rectangle or rectangles, or it's got a little tit on it there, is always negative or odd. The top is always even. So and you can see they've got in between. If you're looking close, you're not going to be able to see these numbers here. They've written a 5 foot in between to make sure you know you're 5 foot plus. Okay? So you're just going to read the rod, and what's going to happen is you're going to record the value. Okay, how do you read the rod? Well, you're going to take the instrument, you're going to set it on the tripod. You're going to use the leveling screws and make sure the level is perfectly level. How do you do that? It's got a bubble vial. So on this is a round vial filled with a liquid, and it's got a little circle inscribed dead center. And then when you look at it, there's going to be a bubble that's floating. The bubble just moves. When you level the instrument, the bubble will keep moving around. And in order to get this exactly where you want it, is you've got the little fixture. You got the circle inscribed in the center of it. The bubble's floating around. You want to put that bubble right there. When the bubble is dead center in that circle, that means that instrument is level. What does that mean? It means if I take and look both directions, this line is perpendicular to the gun. Okay? So I'm putting a line in space, and I'm measuring off of that line. The bottom of the level rod sits on the item that you're trying to find the elevation of. You hold it up. The rodman makes sure the level rod is doing about 3 things. 1, common air. There's no crap on the bottom. If you're out there in the snow, the mud, you can build up on the bottom and there's no crap on it. If there's crap on it, the elevation's not right. So you got to pay attention to the bottom. 2 is they got to pay attention to the alignment. If they lean it forward or lean it back, the number you're reading isn't right. If they lean it to the left or to the right, you're not getting an accurate reading. This one's easy. You can see, you can tell. So all you do is tell me to do something. So if I'm leaning that way, you're going to tell me to move it this direction. So when I move it, then you can say okay. The problem I get is if I'm leaning it this way. You can't tell. So the rodman's got to have enough focus that they make sure this thing is straight up and down. If it's not, I'm reading a number bigger than I need to read. Okay? So the rodman's got some jobs. Make sure there's no crap on the bottom. Make sure it's not leaning this way, which the instrument man can take care of. Make sure it's not leaning this way, which the rodman should have enough focus to take care of. Okay? So you'll read it then, and then you move it to the next point and read something else. And if you want it bigger, it extends. If you want it littler, it collapses. Okay, if you're reading everything below, there's no use having the big thing stick out. You can just have part of it. Okay, you notice I put the rod bottom right here. So I'm reading it. That's the way we typically read a rod. Unfortunately, what if I wanted the elevation of the ceiling? I'm in trouble. So we have to do this. And when I do that, I invert the rod. So when I'm doing notes, I'm putting down my numbers in my notes, I have a regular number. And if I happen to have the rod upside down, I write INV in parentheses behind it. That means the rod is inverted. It's upside down. It's inverted. Anything that has a straight number means that the bottom was down. The inverted means the bottom's up. Okay? So we'll use the rod and we'll take elevations. And elevations then are written down. And on your plans, you'll have elevations of floors, foundations, curbs, all kinds of things, and you have to be able to go and figure out if you're setting the stuff in the proper elevation. And that's what the level does. So if we're going to do that, that means what am I using as my baseline? So I'm going to do this. I'm going to put this guy back here. Somewhere we have to have a benchmark. A benchmark gives us a relative elevation with respect to our project. We have two types. We have the USGS benchmark, the United States Geological Survey, which connects the whole world. And in our area, they're in the 600 series. So a number like this you may see on a drawing. That means that we are about 680 feet above sea level. If you went to Denver, Colorado, the mile-high city, that would be 5,280 range. They're about a mile above sea level. That's why they call them the mile-high city. Okay? So that's the USGS. Highway projects, big federal projects, long-range projects typically use the USGS. If you're on a highway project around here, you're going to see a lot of numbers around 600, 700 range. For a site, if I was building a building here, we typically don't use a benchmark. We use a site benchmark. So by putting an S in front of it, it means the benchmark is relative to that project on that site. A lot of engineers and architects will use 100.00 as a site benchmark. Okay? So I can have two different datums. One is worldwide, USGS, United States Geological Survey. The other is a site benchmark, which is an arbitrary benchmark set by the design professional for that particular site. And a lot of people use 100.00. That's pretty common on a drawing. You look at the drawings, it'll tell you. So I'm going to use a benchmark. So that'll give me my index. So that benchmark then controls every elevation on that project. Everything's related back to that. So in order for me to get dimensions, I need ultimately to start out with this guy and then move them around and set curb heights, step heights, foundation elevations, floor elevations, steel elevations. All that comes off of that site benchmark. So what we're going to do is we're going to show you how you figure them, and it's just up and down. It's just like taking an elevator in a building. Start on floor 0, you go up 5 floors. Now you're at 5 floors. You go down to where you're at floor 3. You go up 5, you're back to floor 7. That's all we're doing. We're drawing a line in space and we're measuring up and down from it. If I know the elevation of this, if I know the dimensions up and down, I can find the elevations of anything. So that's what we're going to do. So in this lesson, what I hope to do is get you in a position where you understand the concept and then how we formally document it if you're in the field that's recognized as being a standard in the industry. So I'm going to do a simple little problem and get you oriented. First of all, I want to make sure you understand the terms. BM is benchmark. SBM is site benchmark. Okay, we're going to end up with a possibility that we're going to look too far for the instrument. So we got to kind of leapfrog. It's too far to see. So we'll do intermediate points. A TP is recognized as a turning point. So let's say I got a site benchmark here. I want to set a piece of steel over here. I can't set up in the middle and see it, so I'm going to set up my gun here, and I'm going to set a temporary turning point. Then I'm going to set my gun up here. Now the distances are small enough that it makes sense, and I can physically see. So it'd be an intermediate point for me to get from point A to point B that I can't physically see with one shot. Okay?